In the heart of the bustling digital age, where information flowed like an endless river, a remarkable phenomenon was taking place. In this world of interconnected devices and boundless data, the creation of digital content had become an art form, one that seemingly required no physical space at all. The internet, a sprawling landscape of information, was often hailed as a realm of pure abstraction, where every text, image, and video existed as mere arrangements of zeros and ones, a world of bits where the concept of physicality seemed obsolete. But in the midst of this vast digital expanse, a scientist named Dr. Emily Clarke was about to embark on a journey of discovery. She was a curious soul, always seeking to unravel the mysteries of technology. One day, while working in her cluttered basement laboratory, she stumbled upon a discovery that would change everything. Dr. Clarke had long been fascinated by the vastness of the internet, a world of bits where content seemingly took up no space in the physical realm. But as she delved deeper into her research, she began to question this assumption. What if, she wondered, the digital world wasn't as ethereal as it seemed? Armed with a state-of-the-art computer, she set out to explore the nature of digital content. Her laboratory was equipped with advanced sensors and monitoring equipment, ensuring that no detail went unnoticed. As she created digital content, text, images, and videos, the computer's ventilation system caught her attention. This was where the unexpected happened. Special sensors designed to track changes in the environment detected something unusual. Tiny, previously unknown particles were escaping into the air through the ventilation system, carried away by the heat generated by her computer. Dr. Clarke couldn't ignore this peculiar phenomenon. To confirm her discovery, she meticulously repeated her experiments, creating digital content again and again, and each time, those enigmatic particles found their way into the laboratory's air. It was a consistent pattern that couldn't be denied. With the newfound particles in her sights, Dr. Clarke conducted detailed analyses. She used advanced microscopy and spectroscopy techniques, peering into the heart of these minuscule wonders. Byteons, as she named them, began to reveal their secrets, eternal, substantial, and born from the world of bytes and bits. Under a microscope, byteons appear as tiny, spherical particles with a metallic sheen. They are so small that they are barely visible to the naked eye. Their color varies depending on their composition, but they are typically silvery or white. The byteons, once released into the atmosphere, didn't dissipate as one might expect. They lingered, forming a digital haze that intermingled with the very air people breathed. But there was a dark side to their presence. Byteons had an insatiable appetite for oxygen molecules, breaking them apart with their digital essence. Dr. Clarke's experiments had uncovered a perilous truth about the digital world. What was once thought to be an abstract realm with no physical consequences was, in fact, embodied by these invisible yet weighty Byteon particles. They were altering the composition of the atmosphere, a discovery that would have profound consequences for life on Earth. Dr. Emily Clarke's determination to understand the elusive Byteon particles had led her down a path of relentless experimentation. She had explored every avenue to control or destroy these digital entities, trying a multitude of methods without success. First, she attempted to physically disrupt the Byteons, poking at them with a needle, hoping to disassemble their structure. Yet, the particles remained steadfast, seemingly immune to her efforts. No matter how precise or forceful her prodding, the Byteons maintained their digital integrity. Next, Dr. Clarke turned to extreme temperatures. She subjected the Byteons to both freezing and boiling conditions. In a chamber designed for cryogenic experiments, she exposed the particles to temperatures that would freeze most substances solid. Then, in another chamber, she cranked up the heat to levels that would vaporize ordinary materials. But Byteons endured these temperature extremes without the slightest sign of breaking down. Radiation was her next approach. She exposed the Byteons to high doses of electromagnetic radiation, thinking that the bombardment of energy might destabilize their digital essence. However, the particles proved astonishingly resilient, showing no signs of deterioration under the radiation's assault. Despite her meticulous experiments and countless hours spent in the laboratory, Dr. Clarke's frustration mounted as Byteons continued to elude her attempts at control. She was on the brink of despair when, one ordinary day, a serendipitous accident changed everything. Dr. Clarke, accustomed to recording her thoughts and experiment results with a pencil, was in the habit of jotting down her findings. The tip of her was coated with a fine layer of graphene, a two-dimensional sheet of carbon atoms. It was an everyday tool for her, and she had used it countless times without giving it much thought. As she was making notes about her latest futile attempts to subdue Byteons, her hand accidentally brushed against one of the particles that had escaped from her experiments. A tiny bit of graphene dust, worn away from the pencil's tip, adhered to the Byteon. In that moment, something extraordinary happened. The Byteon, now carrying this minuscule speck of graphene, began to react. It vibrated with increasing intensity and emitted a faint, ethereal glow. Dr. Clarke watched in astonishment as the Byteon disintegrated before her eyes, leaving nothing but a fading trace of light. It was a moment of revelation. Dr. Clarke realized that the accidental contact with graphene dust had triggered a reaction within the Byteon, leading to its destruction. The remarkable properties of graphene, combined with the inherent digital nature of Byteons, had caused this phenomenon. Eager to confirm her discovery, Dr. Clarke meticulously replicated the scenario. Time and again, she introduced graphene dust to Byteons, observing their consistent disintegration. Graphene, it seemed, had the unique ability to disrupt and neutralize these digital entities. With this newfound knowledge, Dr. Clarke delved into further research. She studied the interactions between graphene and Byteons, meticulously documenting the mechanisms behind this phenomenon. It became clear that the combination of graphene's structure and the Byteon's digital essence led to their mutual annihilation. The accidental discovery had turned the tide of Dr. Clarke's research. Armed with the potent tool of graphene, she was now on the verge of controlling Byteons and mitigating their unintended consequences on Earth's atmosphere. What had once been a humble pencil had revealed itself as the key to unraveling the mysteries of the digital world. Dr. Emily Clarke had stumbled upon a groundbreaking solution to the Byteon problem that could potentially safeguard the Earth's atmosphere from the unintended consequences of these elusive particles. Armed with her discovery, she felt a deep responsibility to share it with the world, especially the government, which could initiate large-scale implementation to mitigate the issue. Taking her research to the highest echelons of the government was a pivotal step. Dr. Clarke prepared meticulously, gathering her findings, data, and a detailed explanation of how graphene could neutralize Byteons. She was aware of the magnitude of her discovery and the potential ramifications for the planet. With a sense of urgency, she presented her solution to government officials, who, in turn, recognized the gravity of the situation. Byteons consume oxygen molecules in the atmosphere. If Byteon levels continue to rise, they could exacerbate the problem of oxygen depletion caused by climate change. This could have a negative impact on both marine and terrestrial ecosystems. However, the implementation of her solution on a global scale was not a task that could be accomplished overnight. In a world where technology and nature collide, what decisions should humanity make when faced with the choice of implementing a global solution to safeguard the environment against unforeseen consequences? Stay tuned to explore how the brilliant minds of the world are going to face Byteon. Thank you for watching. Be sure to subscribe Neural Fiction and stay tuned for more captivating narratives and fresh content. Share this story with your friends and family if you liked it.